This, as you can see, fine young students, is magnetism caused by moving electrons. So, why do moving electrons cause magnetism? That's a great question. And so there's a couple ways. We just know that it's true. Basically, spinning electrons can cause magnetism, so they can move that way. They can also move in a straight line like in a wire, and they have a magnetic field around them. Or they could move in up and down an antenna, and that produces an electromagnetic field, and as it sketches out through the air like a cell phone tower, produces an electromagnetic wave. So electricity and magnetism, I don't know if we really can understand or explain why electricity causes magnetism, but it definitely does. We know that for a fact. Now, if you're looking at magnetic fields around any magnet or moving electrons, they're always going to obey ants. Do you remember what ants is? Whoops, that one tried to get away from us. Ants is away north toward south. So, away north toward south, and then back inside the magnet, see, ants are outside the anthill. You know, you normally see them there. But outside the magnet, they go ants away north toward south. Inside the magnet, they go back the other way to kind of complete the cycle. So the magnet basically acts like a power supply. Now, remember that iron, nickel, and cobalt are your three magnetic metals. And neodymium is a recent one that we have. But the three, that's an alloy. So the three naturally occurring magnetic metals on number 64 are iron, nickel, cobalt. And number 63, the magnetic field lines never cross. Because just like if you're asking somebody where directions go and you're looking for the direction of the magnetic field, if somebody gave you directions and said go that way, that wouldn't be good. That would not help, because you just wouldn't get there. Teslas is what goes on number 65. And Tesla measures how strong or how tough the magnet is. If it has a bunch of Webers, Webers are the arrows. So when you think of Webers, if you see that word, or read it, Webers are the arrows. And how close they are, Webers per meter squared or Webers per area, how tight they are together, that's going to be the strength. Just like if I have somebody who has huge muscles like I do, they have really tight muscle fibers. They're really close together. So a magnetic field that has really close magnetic field lines, that's a very tough magnet, very strong magnet. And so if you look at the example there on the page, actually I don't give it now that I'm looking at it, so let me give you this example. So if I have 2 meters by 2 meters, these represent magnetic field lines coming out at you. It's like looking at the end of the arrow and it's coming out at you. Okay? That was a little 3D action right there. And say each one of these represents 10 Webers. 10 of these arrows. So, if I want to find the Teslas equal Webers divided by area, or meters squared. So what I'm going to do is I have 9 times 10 is 90, divided by 4. 90 divided by 4, so this is going to be 90 Webers, WB, over 4 meters squared. And that will be 90 divided by 4, 22.5 Teslas.